In this video, we're going to take a look at network topologies and how they've evolved over time. We'll be focusing specifically on three topologies you need to know about for the exam: bus, star, and mesh. So the topology of a network is simply the arrangement of all the elements that you need for networking. Here we've got 4 computers, and we could choose to arrange these in a number of ways. Years ago, these computers would have been connected possibly with a bus network, where you have a backbone connection and each individual PC is then connected to this backbone. One of the major disadvantages with this kind of topology is you only needed to get a break in the backbone and all the computers would lose their connection. An alternative approach would be to connect them in a ring, as illustrated here. But again, you've got a very serious problem, that if one of the connections breaks anywhere in the network, then all the computers are going to lose their connection because of the way the ring network operates. There have been a number of attempts over the years to try and resolve this problem. One solution with the ring network was just to introduce a double ring, but of course this introduces a lot more cabling and additional technology, and better solutions were on the horizon. The star network is by far the most popular wired type of network today. Here the idea is that you have a central switch and all the computers connect into that single central switch. One of the advantages here is that if you get a break in one of the connections, then only the computer that's connected to the switch will be affected. In the past, this central switch would probably have been a hub. A hub differs from a switch because it broadcasts the traffic to all computers on the network, and therefore the security is much lower and the bandwidth is also much lower because of the increased traffic. A switch solved those problems by making sure the traffic is only directed to the computer that it was actually intended for. Now, of course, it won't have escaped your attention that there's still a central problem. If the switch happens to break, then all the computers on the network are still going to lose their connection. One solution to the problem is to create what's called a full mesh network. This is where every computer is connected to every other computer. So for example, if we take the top computer, this is connected to the computer on the left, it's connected to the computer at the bottom, and it's connected to the computer on the right. But equally, the computer on the left also needs to be connected to the computer at the bottom and the computer on the right. And the computer at the bottom also needs to be connected to the computer on the right. What we've created here is what's called a full mesh network. Now in textbooks, you're going to see this illustration without the switches shown, and it would look like all the computers are connected directly to each other. Now this isn't strictly possible. You're still going to need a component that allows multiple connections, and in this case we're showing a switch as being capable of performing this task. So one of the clear advantages with the full mesh network topology is if you get a break in any of the connections, you now haven't got a problem because you can route your traffic via an alternative route. In this scenario, however, one of the disadvantages of the full mesh network topology is there's a lot more cabling and switches which are required, and this can be expensive and impractical for a large network. One possible compromise here is what's known as a partial mesh network topology, where not every computer is connected to every other computer, but there are still multiple connections. So for example, we might have the computers connected as shown here. We haven't got a cable between every single computer, but we have got multiple paths to reach the destination. And this is a great compromise on the full mesh network topology. If you step back and think for one moment that these switches could actually be routers on a wide area network, then effectively what you've drawn is how the internet actually works. In terms of being a partial mesh network topology, the routers are connected to other routers, but not every router is connected to every single other router on the internet.